Hey everyone, hello and welcome to Markets Analyzers. Today we are going to explore one of the most exciting developments in India's tech industry, the semiconductor revolution. From smartphones to artificial intelligence, semiconductors are becoming the backbone of modern technology. From local to global, India's semiconductor dream is unfolding. Meet the pioneers, innovators and leaders shaping India's semiconductor landscape. From design to manufacturing, India is unleashing the next wave of tech innovation. So let's dive in and see how India is poised to become a major player in this global market. In this video, we will discuss everything about semiconductors. Please try to watch the video till the end. You will definitely get the value out of the video. First, let's talk about the big picture. India's semiconductor market is growing fast. From $22 billion in 2019, it is expected to reach $110 billion by 2030. That's a 5x growth. If you look at semiconductor market globally, it was valued at $600 billion in 2021 and it is projected to reach $1 trillion mark by 2030. The opportunity is immense given that the semiconductor industry operates as a truly global ecosystem. On an average, each segment of the semiconductor value chain involves 25 countries in its direct supply chain and 23 countries in supporting, according to an Accenture GSI report. The semiconductor product can cross international borders 70 times or more before reaching the end customer. So it's a staggering fact. Furthermore, with semiconductors powering everything electronic from devices on Earth to equipment in space. So with all these reasons, the semiconductor industry is looking as a future. Other than the immense growth potential, incentives offered by Government of India under the India's Semiconductor Mission are making the industry even more attractive. Before COVID, the semiconductor and electronic supply chain was concentrated in China, Taiwan and Europe. However, post-COVID, there has been a dramatic shift where semiconductor players are diversifying their supply chains from being Taiwan-centric to different regions. Because the pandemic in 2020 exposed a major semiconductor supply chain crisis affecting numerous industries. For example, production of a $10,000 car was halted due to a shortage of a $2 semiconductor. Before COVID, almost 80% of semiconductor and electronic supply chain was controlled by three nations globally, countries like China, Taiwan and South Korea. These countries, if they thought, they could have exerted huge influence on other nations which were dependent on their semiconductors. This is also a reason why governments across the world are pushing companies with incentives. It's not only based on supply and demand, but semiconductors now has become a very important to a nation's security as well. But however, it is easier said than done. The semiconductor manufacturing ecosystem is a complex one, demanding specialized technology, advanced skills and precise execution. This is where the big players comes into picture. But before that, let's take a closer look at the semiconductor manufacturing process. There are 7 steps involved in making a semi which is ready to use in the end product like our smartphone or anything for that matter. Step 1. Chip design. Creating a blueprint for integrated circuit. They are the core of electronic devices. In step 1, we kind of create a blueprint on what to design. Step 2. Pre-silicon validation. Testing the design before manufacturing. In step 1, we will create a design. In step 2, we will test the design. This step ensures the design meets specifications correctly and is free from errors. The step 3. Wafer fabrication. In this step, manufacturing the physical chip will be done. Wafer fabrication is like making a complex cake with precise ingredients and instruction. In this step, there will be a wafer. It's a thin, round piece of semiconductor material, usually made of silicon. And this wafer, the chip will be deposited. In step 1, we will create a blueprint for a chip. In step 2, we will validate the chip. In step 3, the chip will be manufactured and deposited on the wafer. The next step 4, wafer level micro bumping. It's a process that creates tiny interconnections on silicon wafers. It basically is connecting the chip to other components. Next, step 5, wafer thinning, dicing, packaging, assembly and testing. It's an essential process which tells us chip is ready. Basically getting the chip ready for use in electronic devices. These 5 steps are the hardest. Next is SMT, surface mount technology. As the name suggests, in this step, we will mount electronic components onto a PCB, printed circuit board. And finally, 7th step, component level assembly. In this step, we will assemble final end product. It could be our laptop, smartphone and everything. So these are the 7 steps involved in a semiconductor preparation process. I hope you understood how a semiconductor is made and assembled. If you like the content, consider to hit like button and share the video with your friends. Next, let's talk about key players in each step and investments they made. So who are the key players in Indian semiconductor industry? Let's take a closer look. The step 1 in the semiconductor manufacturing process is chip design, as we spoke earlier. The players involved in this step is L&T, Larsen & Toubro, by the name L&T Semiconductor Technologies. They will follow this first step. The proposed investment is 830 crore rupees. The second step is pre-silicon validation. HCL Tech, Tech Mahindra, TCS, Infosys, Wipro, and Tesla have been actively involved in providing pre-silicon validation. The third step, wafer fabrication. There are 4 major players trying to get involved in this step, namely Tata Electronics in tie-up with Taiwan's power chip semiconductor manufacturing. The proposed investment is around 91,000 crore rupees. The next is Adani Group. They are partnering with Israel's Tower Semiconductor with proposed investment of 83,947 crore rupees. Along with them, Hiranandani Group and Zoho are also planning to enter into wafer fabrication with investments of around 25,940 crore and 5,800 crore rupees respectively. Next is wafer level micro bumping, and there are no players in India yet in this process. In step 5 again, there are multiple players like Tata Electronics, US-based Micron and few other players. You can see on the screen the players and their investments. In step 6 again, there are no players in India yet. And finally, in step 7, component level assembly, there are 2 companies trying to set up their plants in India, Megatron and Foxconn. Their proposed investments are not disclosed yet. These are the key players in each segment. Next, incentives and investments. The Indian government's Semicon India program offers incentives worth 76,000 crore rupees and they are committed investments worth $17.8 billion. But how does that compare to other countries? Let's take a look. US Chip and Science Act has $400 billion investments committed. Our incentives are less compared to the big giants like USA, but we are doing what we are capable of. Along with that, our state governments too are providing 20 to 25% subsidies to attract investments. Next, let's talk about understanding the semiconductor world. Now let's talk about some key terms. Fabless. Companies that design chips but outsource manufacturing are called fabless. Companies like Nvidia, Qualcomm, AMD are involved in this process. Next, integrated device manufacturer. Companies that design, manufacture and sell their own chips comes under integrated device manufacturer. Companies that involved in this process are Intel, Samsung, Micron. Foundry. Companies that manufacture chips for other companies. Companies like Global Foundries, Intel Foundry Services, Samsung Foundry are involved in this process. Each company will have a different role in the semiconductor supply chain. Next, let's talk about the nanometer story, which explains the technology and its usage. Nanometer technology refers to the size of tiny transistors on a microchip with smaller sizes, example 5 nanometer, 3 nanometer, enabling faster, more efficient and smaller electronic devices. Lower the nanometer, greater the technology. You can read this table by pausing the video. Leading edge nodes 3 to 7 nanometer are used in smartphones, AI data centers. They are leading edge technology. Advanced nodes 16 nanometer to 28 nanometer. They are used for mid-range smartphones, laptops and tablets. You can read the nanometer size and their usage in the table on your screen. Next, let's talk about past attempts and future prospects. India had its share of setbacks in the semiconductor industry, but with government's incentives and private sector investments, the future is looking good. If you look at past attempts, Intel's failed attempt to set up a semiconductor fab in 1969. Along with Intel, few other global companies tried to set up their manufacturing plants in India, but due to government's slow response and few other reasons, they did not move forward. But future prospects are looking great with India's growing talent pool, government support and increasing demand. Next, let's talk about the stakes involved. The semiconductor industry requires significant investments. Silicon fab manufacturing unit requires investments around $3 billion to $30 billion. The compound semiconductor fab investment requires anywhere between $100 million. The investments are very high and the break-even period is also very high. In few cases, it could reach 10 years to reach break-even. But the potential for substantial returns are also very high. Finally, semiconductors are the cornerstone of modern technology, offering both immense potential and significant risk. As the demand continues to skyrocket, those who can capitalize on the opportunity will not only reap substantial rewards, but also shape the future of tech innovation. So to conclude, that's it for today's video on India's semiconductor revolution. I hope you understood what I tried to explain to you. Hit the like button if you found the content informative and subscribe to our channel for more such work. and share the video with your friends to encourage our work. We will come back again with another interesting video. Until then, have a great time.